Good morning, everybody. Good morning. Oh my gosh, I'm sorry. Good morning, everyone. Yesterday, we started chapter 2, solving linear equation in one variable. And we were working on this problem. Solve the equation for x. I think we apply the distributive property and simplify the left-hand side as 4x minus 8. The right-hand side is also 4x minus 8, right? So what do you notice about this equation? Anything special about this equation? Left-hand side is 4x minus 8. Right-hand side is also 4x minus 8, right? Yeah, suppose we apply the technique we learned from yesterday, transposition of terms. Yeah, let's say we bring down the 4x on the left, move the 4x on the right over to the left, bring down negative 8 on the right, and move this negative 8 to the right. We have a positive 8, right? Do you see what happened here? So we move the 4x here over to the left, negative 8 over to the right. Remember, when we apply transposition of terms, we move it and change the sign at the same time, right? Yeah. So on the left, 4x minus 4x, we have a 0. On the right, negative 8 plus 8, we have 0 as well. And what is 0 equals 0? This equation is special. This equation is special. When we try to solve the equation for variable x, we got an identity. Okay? We actually can see the equation is an identity from here. 4x, yesterday we got 4x minus 8 equals 4x minus 8, right? Yeah, left-hand side and right-hand side are identical. Yeah. So the original equation is an identity. What does that mean? Means no matter what x equal to, you can let x be 0 or any positive real number or any negative real number. Doesn't matter what x assume, which value x assume. The left-hand side, 4x minus 8, always equal to the right-hand side, 4x minus 8. So the original equation is an identity. Now, what's the solutions of the identity? All real. Okay, yeah. Our task is to solve the equation for x. We are looking for the value or values of x that satisfy the equation, right? Turns out we identify this equation is an identity. Means no matter what x equal to, the equation always is true. It's always true, right? Left-hand side is always equal to right-hand side. Doesn't matter what value that the x assume. So any real numbers would satisfy the equation. So any real numbers are solutions of the equation. So the solution set of this equation is all real. So you guys want to write it down. This equation is an identity. If the equation is an identity, the solution set is all real. And this notation, fancy R, yeah, represents the real number set. Or you can just write all real or any real numbers, right? Am I clear about this problem? This equation is special, okay? When we try to solve the equation, we identify this equation is an identity. So any real numbers would satisfy the equation. No matter what values you let x take, the equation is always true. If the equation is an identity, then the solution set is all real numbers. Are we okay with that? Okay. Number 4, let's see. The next equation, number 4. From the first example, we got 4 equations, right? Yeah, we did 3 yesterday. So number 4, 2x plus 5 equals 2x plus 6. 2x plus 5 equals 2x plus 6. Yeah, let me rewrite this better. Number 4. 2x plus 5 equals 2x plus 6. Let's see, how do we solve this equation? Of course, we want to isolate x on the left, right? But now we see x is on the right-hand side as well. So would you like to apply the transposition of terms to collect like terms? You see? Same thing with yesterday. This term and this term, they are variable terms, right? Yeah, we want them on the left-hand side. And those two terms, they are numbers, constants. We want them on the right-hand side. We want to collect like terms. One easy way to collect the like terms is to apply the transposition of terms. Yeah, we can move those terms around. Yeah, just remember, when we move one term from one side to the other side, we need to change the sign to the opposite. Okay? Yeah, I give you 1 minute, a couple of minutes. Can you work on it on your own first, please? And let me know what you have after you collect like terms. You can move the green over, change the sign. You can move the orange over to the right-hand side, change the sign, right? And let me know what you have. And look for solution. You need to have an equation, right? So what's the left-hand side? What's 2x minus 2x? Yeah, 0. Exactly. Good job. I'll explain in a moment. When you move the terms around, you want like terms on the same side. You want this 2x and the other side, right? And you move it and change the sign, right? You move it. You become negative 2x, right? Yeah, negative 2x. You don't have to, if you like the other method, you can minus 2x from both sides. That's totally okay, yeah. This is the left-hand side, this is the right-hand side, right? You minus 2x for the left, and you minus 2x for the right. Okay, you don't want to have. So which method do you want to learn? Which method? Huh? The transposition of terms? Okay, that's cool. Yeah. So you see, this term 2x doesn't change nothing. All you do is you bring it down. Okay, right? So you don't change the sign for that because you didn't move it. What you moved is this guy. You moved it over. That's why it becomes negative. Remember, the equal sign is an anchor. It doesn't change it, right? And then this 2, you can do anything. But that's not to the 6. This 6 doesn't change because you simply just bring it down. It remains on the right-hand side, right? And this 5 was on the left, but you do not want to be on the left. It's a constant, you want to be on the right. Yeah. So you move it over. It was positive, but you move it, change it to negative. And then the purpose is to make those like terms on the same side, then we can combine them. If the like terms are not on the same side, we cannot combine, right? Very good. Just a practice. You have, okay, very good. Perfect. That means you have, what method did you apply? The transposition terms, yeah, exactly. So you move this 2x over, right? So that's negative, that's perfect. But you didn't change 6. It's supposed to still positive. You move the 5 over, so you should have a negative 5. Yeah, very good. So I'm happy that you guys want to try my method. It is a very good and a convenient method. Yeah, this equal sign serve as an anchor, right? It's gonna be there. Yeah. Whatever on the left, that's the left-hand side. Whatever on the right, that's the right-hand side. Okay, let's see. How do we apply transposition of terms to collect like terms? The blue term do not change. Blue term is on the left, now it's still on the left, right? Doesn't change anything, so just copy it. And a green term, you want a green term on the left, right? So you move it. You move it over. You have to change the sign to the opposite. So positive 2x change to negative 2x. Yes, the green one. You move positive 2x over, you have negative 2x, right? Does that make sense? Yeah, to the left, yeah. So the 6 in purple, that one doesn't change. So you don't change the sign. 6 doesn't change, it's still on the right-hand side, right? Yeah, and then you want to move the 5 in orange over. So you move it and you change the sign. So the orange become negative. So look at the two equations. What happened is we move the green over, change the sign, flip the sign. We move the orange over to the right, flip the sign. Blue doesn't change because it's still on the left all the time. The purple doesn't change. Positive still positive, right? Because you didn't change the sign. Okay, very good. Now we have those like terms collected. On the left, we have 2x minus 2x. What is it? It's 0, right? Yeah, 2x minus 2x is 0. On the right, 6 minus 5 is 1. Is 0 equals 1? Yeah, by the way, all the transformations we did are equivalent. Means this equation is equivalent to original equation. So the solutions of this equation is the same with the solution of the original equation. Does this equation have any solutions? 0 equals 1. 0 equals 1 obviously is a contradiction, right? Yeah. So if 0 equals 1 is a contradiction, means the original equation is also a contradiction. Means what? Means no matter what x equal to, the equation is always false. See that? Then no matter what x equal to, this blue and this green cancel each other, right? We always have 5 and 6 equal to each other. That's always be a contradiction. So what do you think the solution of this equation? Do we have any real numbers that satisfy the equation? Do we have any real numbers that couldn't make the equation be true? No. So no solution, okay? Yeah, so I want you to write it down. If the equation is a contradiction, solution set is empty. And the equation has no solution. Equation has no solution. Yeah, you know, all my problems in the test are multiple choice question, right? So if you see the equation is a contradiction, then you're gonna look at A, B, C, D, you're gonna choose no solution. Okay, no solution. Does that make sense? Okay, so from those 4 examples, we practiced the very useful technique, transposition of terms. Also, you see 3 different types of equations, linear equation in one variable. Yeah, let's look at this table. We have 3 types of linear equation in one variable. They are conditional, identity, contradiction. Yeah, let me show you what kind of equation is conditional, what kind of equation is identity, what kind of equation is a contradiction. Okay, 3 categories. Yeah, let's go back the example we seen earlier yesterday. So this is the first problem, right? This is the first problem, and we solve this equation. We got a solution is 3. Yeah, the equation has 1 solution only. Yeah, finite number of solutions. Yeah, 1 solution only. So the equation is conditional. An equation is conditional. means this equation is true, is correct. Yeah, this equation is true under the condition that x equals 3. Only under that condition, that equation holds. What if x assume other values? For example, x equals 0. Then the equation is false, right? You can try. When you plug in x equals 0, the equation will not be true, right? So the equation is only true under the condition that x equals 3. So the equation is conditional. Does that make sense? The name, yeah. So an equation is conditional if the solution, if the equation has a finite number of solutions. One solution is finite, right? So it is conditional. Yeah. So for us, all the conditional linear equation in one variable always have one solution only. So once again, conditional, okay? And what is identity? Identity is the one we saw earlier today. Identity means when we try to solve this equation, we got an identity. It's always true, right? Left hand side is always equal to right hand side. So the solution set is all real. Any real numbers will make that equation be true. So in this case, the equation has infinitely many solutions. All the real numbers are solutions. So that's the second type, identity. Solution set, all real. Second type. Third type. Third type is the contradiction that we saw earlier. So you solve this equation and you got a contradiction. And that means no matter what x equals 2, the equation is always false. So the equation is a contradiction and the equation has no solution. Okay? Yeah, 3 types. Let's look at the table again. You will have something like that in the test 2. I will give you a conditional, I'll give you an identity, and give you a contradiction. And ask you to solve it and identify the solution. You can see here, conditional, one solution. Solution set contains one number only. Identity, infinitely many solutions. Solution set contains all the real numbers. Contradiction, no solution. Solution set is empty. All right, are we good? All right, so now let's move to next example. In the next example, the equation contains fractions or decimals. Yeah, unfortunately. Yeah, we're gonna see some examples of linear equation in one variable. And the equation contains fractions or decimals. Yeah, not make the solution might be more challenging, but we will figure it out. And before that, let's look at the guideline here. We have this guideline yesterday, right? But it's different. Yeah, this one has a fraction or decimal. Solving a linear equation in one variable. Step 1, simplify each side separately. Use the distributive property as needed. Clear any parentheses, clear any fractions or decimals. Yeah, so this is new. Clear any fractions or decimals. Combine like terms. So you don't like decimals. You don't like fractions. I believe you compared with those, you prefer whole numbers, right? I believe that. So why don't we clear fractions or decimals at the very beginning? Step 2, isolate variable terms on the left. Use the addition property of equality. So you can use the transposition of terms here. Step 3, isolate the variable x. Step 4, check your answer. So step 2, 3, 4 are the same with yesterday. The only thing different is the beginning. If the equation has a fraction or decimal, you want to clear them out the very beginning. Okay? Let's look at the examples. I'm going to copy this part somewhere else, then we can have a bigger space to process them. Let me Let me process it here. So far so good, everyone? So far so good? Yeah, we are working on solving linear equation in one variable. Yeah, every example you can see the problems are getting more complicated. Number 1. This equation is 2/3 x minus half x equals -1/6x minus 2. Does my 6 look like a B though? I'll try to write it better. Yeah, 1/6x minus 2. All right. This is a good example, all right? Yeah. It has fractions as coefficients. Okay. So how about let me show you 2 different methods and you tell me which method you like better, okay? The first method, I'll just process those fractions as regular numbers. Yeah. Look at the terms in the equation. Tell me how many terms do you see in the equation? Please tell me how many terms do you see in this equation? Everyone, how many terms? 4 terms, right? I just color them differently. Very good. 4 terms. How many of them are variable terms? Variable terms. We talked about this concept yesterday. Variable terms are the terms contain variable x. It's different from a constant term. So which of them, we have 4 terms, right? Which of them are variable terms? Yin, which of them are variable terms? Is the blue variable term? Is the green variable term? Yeah, is the purple variable term? What about the orange? Orange, yeah, you're right. Exactly. We have 3 variable terms, right? So remember, we want variable terms are together. Yeah, again, this is the anchor. Yeah, this is the equal sign. On the left, blue and the green already variable terms. We want to move the purple over. Do you agree? We want to move purple over, right, to the left. Okay, so this is what I'm going to do. Bring down blue. Nothing changed because it's still on the left. Oops, that's blue, right? Still on the left. Nothing has changed. Copy green. Nothing has changed. Move purple over. Yeah, purple is negative. So when I move purple over to the left, do I need to do anything special? When I move the purple over, the purple is a -1/6x, right? When I move it over, do I need to do anything special? Transposition of terms. Yeah, what is it? Yeah, awesome. Thank you. +1/6x, right? Yeah, that's what we need to do. Flip the sign. It's easy to do, right? Move it over and flip the sign. Negative becomes positive. And on the right-hand side, the orange is by itself. The orange is by itself. Okay, you see, as I said, the transposition of terms is very convenient, right? Yeah, now you have all the variable terms on the left. The single constant is on the right. Yeah. So on the left, all the 3 terms are like terms now. Can we combine like terms? 2/3x minus half x plus 1/6x. We combine like terms by combining what? We combine like terms by combining their coefficients. Okay, tell me, the blue, what's the coefficient of the blue term? Coefficient of the blue term. Coefficient is the number associated with the variable. Yeah, what's the coefficient of the blue term? 2/3. Yeah, exactly, 2/3. And what's the coefficient of the green term? -half. Okay, yeah, the constant coefficient is the number multiply with the variable, right? So negative half, very good. And what's the coefficient of the purple? What's the coefficient of the purple? Positive 1/6, right? Yeah. We combine like terms by combining their coefficients. Okay, we copy equal, we copy -2 on the right hand side. Okay, now I'm gonna give you a couple minutes. You tell me how do you find the sum of 2/3 minus half plus 1/6. In chapter 1, we didn't learn operations with fractions, right? Yeah, but now we have 3 fractions, the same thing, okay? The same thing. Do they have the same denominators? Do they have the same denominators? The denominators are 3, 2, 6. They're different, right? Yeah, we need to find the least common denominator. Least common denominator of the 3 fractions is the least common multiple of the 3 fractions, of the 3 denominators. So 3, 2, 6. Okay, I'll give you a couple minutes. Yeah, that's something we learned from chapter 1. Yeah, anyone could tell me what's the least common denominator? Least common denominator. Yeah, least common denominator. My special case number 1, special case number 2 actually still works. Even we have 3 numbers here. I'll give you a hint. Give you a hint. Special case number 1. And what's the least common multiple? When I said what's the least common multiple of 3, 2, and 6? Yeah, exactly. The smallest common multiple, right? 6 is the multiple of 3. 6 is the multiple of 2. 6 is the smallest multiple of 6, right? So that makes 6 the smallest common multiple of all the 3 numbers. Yeah, it is my special case number 1 because 6 is the multiple of 3. 6 is the multiple of 2. So the bigger number is the least common multiple, right? And you're gonna write all of them, all the 3 fractions, as their equivalent fractions with denominator 6. Yeah, I want you to do that. Can you do that? Even you go to higher level mathematics class, you won't avoid dealing with fractions. This one, top and bottom, you want to double it, right? 2/3. Both numerator and denominator multiplied by 2, right? Yeah. And 1/2, both top and bottom multiplied by 3. Remember that? Remember that? This one talked about extract. So 2 over, you want this 3 become 6, right? Okay. Double it, right? Right? Yeah. And you have to do that same thing in the numerator. And that part becomes 4/6, correct? Yeah. And this 2, you want to change to 6, right? You triple it, right? Oh, sorry. Yeah, triple it. And then you do the same thing on the numerator. So you have the negative, doesn't change the sign. It is negative 3/6, right? this is correct. That's correct. 2 over 6 is 1 over 3, right? Very close. Very close. So let's look at it together. The first fraction, 2 over 3. If we double both top and bottom, we can write the denominator as 6, right? So the first fraction, 2 times 2, 4. 3 times 6. Second fraction, both top and bottom multiply by 3. So that is negative 3 over 6, right? And then plus 1 over 6. Do you have that? Do you have that? Right? Okay, very good. And inside the parentheses, remember, please excuse my dear Sally. We're gonna see what's the sum inside the parentheses. Yeah. Keep the bottom, because all the 3 fractions, they have the same denominator, right? The rule is to keep the bottom, solve the top. 4 minus 3 plus 1 times x equals 92. Okay, let me erase this part. What is the 4 minus 3 plus 1? 2, yeah. Could we reduce 2 over 6? What is it? 1 over 3, x equals 92, right? So you should have that, right? Everybody? Yeah, you are solving equation. So every step you have an equation. You don't do this. I mean, you don't have two equal sign in the same line. Every step, every line, you only have one equal sign, right? Left hand side equal right hand side, yeah. Okay, what is the coefficient of x right now? 1 over 3, right? Is it a fraction? There is a sentence I made you to write down yesterday. Yeah, when we try to isolate x, if the coefficient of x is a fraction, we are going to multiply both sides by the reciprocal of the coefficient, right? Yeah, what's the reciprocal of 1 over 3? Yeah, it's 3, right? Very good. So we are going to multiply each side by 3, or 3 over 1 by 3, right? Okay, then this guy, this part, 3 over 1, 1 over 3, cancel out. Just the 1, right? And we have the x on the left. On the right, we have negative 2 times 3. That's negative 6. Does that make sense? That's the first method. That's the first method. Second method. Let me show you second method. Two over 3x. Let me copy the equation again. Minus 1 over 2x equals negative 1 over 6x minus 2. Yeah. The second method, I know most of you hate fractions. Yeah. So the second method is we are going to get rid of the denominator the very beginning. So how do we get rid of the denominator at the very beginning? This is how. So firstly, we identify how many denominators do we have. We see the denominator here, we see denominator here, we see denominator here, right? And in this specific example, we only have 3 denominators, right? Okay, we're gonna copy them down. We have 3, 2, 6, yeah. And then we are going to find the least common multiple for them. Vanessa, what's the least common multiple of 3, 2, 6? Yeah, you know that. Very good. We had this step earlier, right? So both methods you have to do this anyway. Yeah. So the first step, you identify all the denominators and find the least common multiple for them. And how are you gonna use the least common multiple you just found? This is how. And then you are going to multiply each single term in the equation by the least common multiple you just found. Let me write it down. You are going to multiply each single term in the equation by the LCM you just found. Can you write it down too? Yeah, write the sentence. You are going to multiply. Yeah, that sentence tell you what to do, right? Yeah, multiply each single term in the equation by the least common multiple you just found. In our case, it's 6, right? Let me show you what I mean. How many terms in the equation again? How many terms? How many terms in the equation? 4 terms, yeah. So be very careful. You are going to multiply all the terms in the equation the same way. Okay, yeah. It's like if I'm a teacher, I treat you guys differently. You guys not happy, right? I have to treat everybody the same way. Same thing, you're going to treat every term in the equation the same way. You are going to apply this treatment. What treatment? You are going to multiply first term by 1 over 6. By 6, which is 6 over 1, right? And second term multiply 6 over 1. Third term multiply 6 over 1, and this multiply 6. 6 over 1 and 6 is the same thing, right? Yeah. And why do I write 6 here and 6 over 1, the other 3 terms? Yeah, because this is a whole number. So 6 would be easier to process, right? And because those fractions or those coefficients are fractions, so I write 6 as 6 over 1. Then later it will be easier for me to process the product of the fractions. I'll show you. So you see 1, 2, 3, 4. Everybody multiply by 6, right? Every single one. Be careful with the sign. Be careful with the sign. Let's see this guy. Let's see this part. How do you simplify this part? What is 6 over 1 times 2 over 3? How do we multiply two fractions? Multiplying two fractions, my method. Vertical, vertical, diagonal, diagonal. Remember that? Yeah. You can see how convenient my method is. Let me show you how convenient. This diagonal, 6, 3. What's the GCF? 6, 3. What's the GCF? 3, right? 3. 3 goes into 6 twice, right? Does that make sense? Yeah. So 3 gonna become 1. 6 gonna become 2. Do you see that? Yeah, diagonally the denominator are gone. Denominator becomes 1 right away, right? Yeah, left top is 2. 6 becomes 2. Do you see we still have a 2 in blue? Right top? Yeah. So after we simplify the coefficient, do we actually have 4x for the term? Yes or no? Please, do you see that? Angela, do you see that? Okay, yeah, in the numerator we have 2 times 2, so that is 4x, correct? Lauren, do you see that? Okay, Ian, do you see that? Okay, let's see the second term. Let's see this guy, this part, okay? Diagonally, 2 is gone, right? 2 and 6, 2 is a factor of 6, so 2 becomes 1, 6 becomes 3, correct? Okay, so what's the second term? Second term becomes negative 3x, correct? Negative 3x. Do you see that? Okay, on the right, you see how convenient this is. 6 over 1 times 1 over 6. The two numbers are reciprocal. What's their multiplication? Reciprocal multiply to, reciprocal is multiply to, don't tell me 0. Multiply to 1, okay? Yeah, 6 cancel 6. So you have negative x on the right. And what is negative 2 times 6? Negative 12. Correct? Do you see that? And that's how do you get rid of denominators at the very beginning. It might look challenging, even more challenging than the first method, but I would recommend you learn this method because if you go to intermediate algebra, chapter 6, yeah, you wanna learn this method. This method has more general application. Yeah, we haven't done yet. Let's see how do we continue here. We want to simplify both sides separately. On the left, what is 4x minus 3x? 1x, very good. On the right, we have a negative x minus 12, right? Do we want to move this guy over? Right? That guy, the blue one, that's the variable term. We want it to be on the left, right? Okay, let's move it. We copy this orange. This orange is still x, right? The orange. And we move the purple over. Move it and change the sign. And on the right hand side, we still have negative 12. So again, transposition of terms. You need to practice. Are you guys doing my lab math? Yeah, there are many problems that you can practice on. Yeah. So press again. On the left, right now we have x plus x. What is it? 2x. On the right, we have a negative 12. One more step. What do we do? Divided by 2. 2 cancel 2. We have x equals what? Negative 6. The same as earlier, right? Yeah, if you have extra time, it's always good. You can plug in back your proposed solution, plug in back the original equation to see if it really satisfies the equation. Tell me which method do you like better? Method 1, method 2. You like method 1? Okay. So who likes the second method better? Nobody likes the second method? And that actually is the recommended method. Because you can see the guideline here. Remember the guideline here. You want to clear the fraction, the very beginning. Either the part in blue, clear fraction or decimal, the very beginning. So the second method is the method that I recommend. Another reason is because when you go to intermediate algebra, that method has better application. You have to learn it anyway. Okay? Yeah, it seems like more complicated because multiply everything by the least common multiple seems like challenging. Do you guys have the notes? Method 1, method 2. Okay? Yeah, you can take a quick picture of this example. I would recommend that you repeat this example. Okay? All right, let's move to number 2. Number 2, the equation is 1.5x minus 3 equals 2.2x plus 11. For this problem, I will also use 2 different methods to process it. Yeah, the first method is the recommended method from the book, like clear the decimal from the very beginning. But this time I would recommend the second method. Okay, yeah. So the first method, clear the decimal the very beginning, because sometimes the decimal confuses people, right? Yeah. So this is 1.5 and 2.2. Okay. We have decimal point here. We have decimal point here. Since both two decimals in this equation, they only have 1 digit to the right of the separator. So we are going to multiply everything by 10. Okay? We are going to multiply all the terms in the equation by 10. Okay, so 1.5x multiplied by 10. Yeah, let me use the small cross as the multiply. It's not the x, by the way. And second term, negative 3, we multiply by 10, equals on the right hand side, 2.2x multiplied by 10, and the last term, 11 multiplied by 10. So everybody multiply by 10, right? You might wonder, why do you multiply by 10? Why don't you multiply 100 or 1,000? The reason I multiply by 10, because there's 1 0 in 10, and 1.5, 2.2, both of the two decimals in this equation, they only have one digit to the right of the separator. That's the reason, okay? And 10 would be enough to change the decimal to the smallest whole number. What is 1.5 multiplied by 10? 1.5 multiplied by 10. 1.5 multiplied by 10. We talked about this before. We multiply number by 10 is equivalent to move the decimal point to the right one time, right? So do we have a 15? Yeah. So 15x exactly. And what is 3 times 10? 30, right? So negative 30. On the right hand side, what is 2.2 multiplied by 10? 22, right? Same with earlier. So 22x. And what is 11 times 10? 110, correct? Now the equation looks normal. We don't have decimals anymore, right? Okay, now let me color them. Blue, this is green, this is purple, this is orange. 4 terms, I believe you see that. Do you see the blue and the green? They are like terms, variable terms, right? Yeah, they are going to go to the left. Green and blue go to the left. Orange and the purple are going to go to the right, right? Yeah, okay. So for the blue, we copied it down. Don't change blue because blue always on the left. We didn't change the side, right? Like you didn't move to, I don't know, to New York. So you know what I'm saying? You didn't move. You are still here. So nothing has changed. You move the green to the left. Do you change green? Change to what? Negative, right? Do you see you move green to the left, positive becomes negative, right? Okay, on the right hand side, we should still have the purple. Purple doesn't change the sign, so it's still positive. We want to move the orange to the right hand side. Negative becomes positive because you change the sign. You change the side. This word I'm talking about. Because you change the side of the term. So you have to flip the sign of the term. So press again. And what's on the left? What is 15x minus 22x? Minus 7x. Very good. What is 110 plus 30? 140, right? How do we isolate x? Divided by what? Negative 7, right? Yeah, negative 7 this time because the coefficient is negative 7. Negative 7 over negative 7 cancel, so we have an x on the left. What do we have on the right? Are we going to have a positive number or a negative number? Negative what? 20, 20. Perfect. So that's the first method. Yeah, by the guideline, we clear the decimal very beginning, right? I showed you how do we clear decimal. But I would recommend the second method for this type of equation, for the reason that you will have a calculator. Yeah, let me copy the equation again. 1.5x minus 3 equals 2.2x plus 11. It's not a fraction. It's difficult for you to handle fractions in the calculator, but in a decimal, calculator is very good at decimals, right? Okay, so let me do the same thing. I'm going to color them blue, green, orange, purple. 4 terms. Blue term remain on the left. Green term move to the left. So green is gonna change the sign, negative 2.2x, right? Do you see that? Green moved over. Positive becomes negative, right? Okay. On the right hand side, 11, purple doesn't change. Purple is still on the right hand side. The orange, because you want to move it to the right, so negative becomes positive, right? You see that? Same with what we did earlier. Okay. Now you can combine like terms. Yeah, on the left, 1.5x minus 2.2x. What's the coefficient of the blue? Coefficient of the blue. Yeah. What's the coefficient of the green? Negative 2.2, right? Yeah. Combine like terms is to combine their coefficients. Combine their coefficients and bring down the variable x. On the right, what is 11 plus 3? 14, right? Okay, do you have a calculator? Good news, from the second test, you are able to use a calculator, right? So tell me, what is 1.5 minus 2.2? What is 1.5 minus 2.2? Negative, Lauren, what is it? Negative 0.7, right? Am I right? Okay, very good. And one more step. How do we isolate the x? Yeah, divide both sides by the coefficient, right? The coefficient we got is negative 0.7, negative 0.7. So they cancel, x is isolated on the left. And you use a calculator again. Yeah, you will have a negative answer. What is 14 divided by 0.7? Yeah, the same thing, right? So tell me, these two methods, which one do you like better? I would say second method. Yeah, I would say second method because you have a calculator. I don't really worry about the operations with decimals. Calculator is very good at operating decimals. Okay, so that's how do we solve equations, linear equation in one variable. Thank you guys for coming. I'll see you tomorrow.